This is definitely, thank you. This is definitely a work in progress, so I'll appreciate all your comments. And yeah, I'll just pause in between, but if there's something unclear, also just feel free to interrupt me. Because I think, because this is also quite a new topic that I'm working on, and I'm sometimes a little bit confusing. So just interrupt me if I don't make sense. So yeah, in this project, I'm looking at the effects of innovation on regional employment and earnings. And I'm considering regions in France, Germany, and the UK. So the motivation for this project sort of comes from this literature around the sort of innovation multiplier and the effect innovation overall has on local employment and local development. So in these papers, and I'm specifically thinking about Moretti and his new economic geography of jobs, new geography of employment, new geography of jobs, where he's sort of thinking as jobs and innovation as mainly being high paid. And because they are high paid, they create a consumption multiplier through local service employment mainly. But what I'm asking myself is so is there actually any additional effect from the innovation activity itself, rather than those jobs just being high paid? Or to put it another way, is there a difference between an innovation worker and, say, a banker? Both of them are high paid, both of them spend a lot of local services, but is there some additional effect from the innovation? And I think that has policy relevance because a lot of local development strategies, industrial strategies, focus on innovation. And of course, innovation is good in itself in a lot of contexts, but does that really make sense from this sort of local development strategy perspective? And just to make a bit clearer what I mean, I just picked out this example. So this is a firm from the region where I grew up. They're sort of an electronics firm. They automate things basically. So they work with sort of manufacturing firms to automate manufacturing processes. They also make audiovisual installations, that sort of stuff. So it's quite high tech. They are one of the biggest patenters in the region. So of course they employ a lot of sort of engineers, people with advanced degrees, who develop these sort of machines or these sort of technologies and work on those patents. But they also employ, and that's what we see in the right picture, they employ lots of people who don't necessarily have a university degree. So they have a big apprenticeship program. That's probably something a little bit specific to the German context, but basically they also employ lots of people who sort of work on actually manufacturing, installing, maintaining these sort of appliances that they develop. So this is sort of the mechanism that I'm interested in. Does the innovation actually lead to these sort of intermediate jobs that are not, say, working on developing the patents, but that are also more advanced than just standard local service jobs? So what I'm doing in this paper is I'm estimating the effect of patenting and graduate employment on non-graduate employment and wages in Germany, France, and the UK. And I'm doing that at the NUTS 2 level. What I'm trying to do to sort of get at this mechanism is that I'm trying to separate the graduate employment shock or changes in graduate employment overall into a change in graduate employment that's due to innovation and a share that's due to other shocks. And I'll talk about that in more detail in a minute. So what I'm finding is that first of all, graduate employment does respond to innovation shocks. So innovation and graduate employment sort of depend on each other. And I also do find that innovation has a positive effect on non-graduate employment, particularly in Germany and France. In the UK, there's not so much of an effect. In terms of the effect of graduate employment, the effect on non-graduate employment is a bit mixed and depends a bit on the country context. I do find a positive effect on earnings as well, but just in terms of levels and not in terms of growth rates. So here's where I think this fits into the literature. So there's actually a paper that just came out over the summer that's quite similar in setup. That's the paper by Eberle, Bremer, and Mitze. And they look at Germany only. And yeah, basically look at a very similar sort of mechanism, the effect of innovation on employment. And they sort of consider different sources of R&D funding and how they affect employment. Then there are several papers that look at the effect of R&D or tech employment on low skills employment. And there's a paper by Carolin Ioramashvili for the US, and they find a positive effect on employment and wages. However, Neil Lee and Stephen Clark for the UK, they're basically running a very similar regression. They also find a positive effect on employment, but they find a negative effect on wages, particularly because these jobs that are being created, they tend to be sort of on the lower end of the labor market. So they are in sort of, sort of coffee shop jobs, lower paid ultimately. There's also some evidence at the micro level, at the firm level, that innovating firms and specifically patents do have a positive effect on wages at the firm level. And lastly, and that's important from my estimation strategy, that there's this positive link between graduate employment and innovation, so that both obviously graduates who work in innovation increase the number of patents that a region produces, but also innovation and innovative regions attract lots of graduates. Yeah, I think I'll go through this slide and then maybe I'll pause for questions. So basically the way I'm thinking about this is that innovation depends on skilled workers. So they produce innovation in a region, or they produce patents in a region. Innovation then also increases demand for skilled workers. So that would be if the innovation sector increases, but it might also be due to skill bias technical change, that more innovative regions attract and require more skilled workers. Skilled workers in the innovation sector consume local services, so that would increase non-graduate employment in the region. But innovation itself might also increase the demand for non-graduate workers, for example, in support roles or in a manufacturing sector that is sort of attached to the innovation sector through the translation of the innovation into new projects or the application of those new technologies. And basically, the way I'm thinking about the effects on wages, I would on employment, I would also expect that an increase in employment would increase wages. So maybe I'll stop here if there are any questions so far.
Cool. So if anyone has any questions, you're free to speak out now. You can also type a question into the chat box and we can relay it to Carolin.
Carolin?
Yeah.
Hi, this is David Rigby. Given your interest in the nature of employment and the links between innovation and employment, both in terms of high skill, high wage workers, low skill, low wage workers, it might be fun to play around with a measure of wage inequality or, some sort of employment growth gap between high skill, low skills on the left-hand side. I just throw that out. There are a number of early attempts to look at innovation and wage inequality. I don't think many of those papers are all that good in terms of the model specifications are a bit weird, and there is a lot of endogeneity, but again, I think that might be fun to play with.
Okay, yeah, thank you. That would be interesting. You'll see, like, I'm kind of struggling with the data side. So it's a bit, so far, I'm just looking at graduates and non-graduates, and I'm trying to get better data. I'm playing around with the European social survey at the moment, but that's an interesting idea to just look at wage inequality. That might be interesting. Yeah, that might be an interesting other dependent variable. Thank you. Sorry, was there something in the chat?
There's a question from Michael in the chat box. Michael, I don't know if you want to read or if I should go ahead and just read it for you.
I can read it. So I'm just wondering how you're imagining the channels respectively for the skilled or the graduate side and the unskilled on the other side. And that's the first part. And the second part would be, what about the supply side dynamics, meaning sorting and migration into a region?
Yeah, so that's a bit of a difficult one. So yeah, the channels are different and I'm estimating them separately, but I think I should probably do more in terms of looking at different industries as well, because at the moment I'm sort of lumping everybody together. So I think there are different channels, and obviously among non-graduates there are sort of different, yeah, there are these sort of local service workers, and then there are workers who work in the application sector basically. And yeah, I can't differentiate them yet, unfortunately, but I have some graphs in the end where I can show you the new data that I'm working with, and maybe that might help a little bit. But yeah, I think the channels are definitely different and they should probably be distinguished.
And let me suggest two plugins here. They're just coming to mind. One is, I'm pretty sure I think it's a Bartik multiplier that it's called in America, where I know because I teach this at some point, but there's the relationship between expansion of the core and population change. And I believe there's a standard Bartik coefficient that's used for that. That's pretty high. In other words, so you're having a very strong supply for every creation of a new job in the core, you're having a pretty strong population response in the long run. So that of course affects something about wage determination. It certainly affects per capita income in a huge way. And then the second thing, is and you know this because we've talked about it, the recent Autor findings, which are that geographically wages for the skilled have become strongly positive. But no, the geographical gaps in wages for the skills have become greater in America, but the geographical gaps in skills for the unskilled have flattened, right? They've been reduced, which means, and that goes, I think ties into Dave's point about it's where you would expect it to come out as an inequality between skilled and unskilled wages. So all of that's going to be, I think you've got to think about all that in the setup or somehow.
Yeah, so I think that's why, that's where I definitely have to sort of differentiate by industry, because yeah, you're exactly right. The problem that I'm having is, so I'm just measuring employment, right? I don't even, it's not really at a population level, as it's at an employment level. So if more innovation in a region means that somebody without a graduate degree, they go from working in the sort of local service economy to working in the local manufacturing economy, or working in a sort of higher skilled job. That's the bit, like, that's the problem, because I just measure degree, that doesn't really measure skill, right? So if people actually have more skills but don't have a job in like in the sort of in a job that they are kind of qualified for. So yeah, I think that's something that would be interesting to look at, exactly whether more innovation in the region reduces this Autor effect. So whether more innovation actually reduces the wage gap between high and low qualified.
I mean, just last point here. I mean, to some extent, I think we're on the grounds of when you think about it, at least in terms of theoretical setup, is whether you're thinking of it, let's just use two extremes. One is like, you could imagine a closed regional economy framework where your latter point becomes relevant, which is like a vacancy chain. And so, you know, there's an innovation expansion, people move into it, and then other people there somehow transition up the ladder. And you know, there's a literature, but it's in another context, about deindustrialization, where we've mostly found people, as deindustrialization happens, people, they do negative shifting, negative occupational or industry shifting, right? That's a problem. But here, like, imagine that's just one question. Then the other question is how, in other words, are you imagining also people coming in? So it's a question of, well, like, how are people at the bottom going to shift up? That's one issue. But also, what maybe they won't. Maybe just all the skilled are going to be expanded by people coming in, and there are no spots for the people at the bottom to shift up to. In which case, I mean, there might be some like general demand side effect, but not very much occupational specific switching that would enable people to improve their position in the labor market.
Yeah,
I mean, that's pretty, you know, I mean, it gets pretty weedy thinking, you know, in terms of like theoretical setup, not to mention the data, which are also hard to do all those things with, but just throwing it all out there to think about.
Yeah, I think another thing to think about in that context also just that I think country specific, it's very different, because I guess in the UK, I would think it's probably, either people move in to take these jobs or it's sort of up moving in the labor market, but then the number of jobs wouldn't necessarily change so much unless people come in. But like at the national level, it would stay the same. In France, where unemployment is much higher, I think it would probably be more that people would shift out of unemployment into employment, because in the UK, unemployment is basically zero. And in Germany, it's also getting to that level. And I think the mechanisms across those countries would be quite different as well. Yeah. Okay, should I?
So Carolin, I had a very quick maybe comment or something. Just I don't mean to give you too much to think about, but I was just wondering, is there also a geographical distribution to automation and jobs being lost as a result of innovation? Or can you assume that those are, you know, geographically comparable everywhere, and so don't really have to enter your theory?
Yeah, that's another question to think about. So I think the way I'm looking at it, that's less the case. But so if I'm thinking that, the innovation creates these jobs and people work on applying it or producing in that sector, it probably wouldn't. But then if in the same, say, take my automation firm example, if they sort of sell their technology in the same regions, that might also result in losing jobs somewhere else. So that's another sort of complicating factor there. Yes, so there might be sort of offsetting trends as well, that jobs that do get created somewhere, but they get lost somewhere else. So it might be, again, something that sort of more detailed industry data might pick up a little bit. But thank you. I think that is another problem. Yeah. Sorry, was there another?
So we also have a question from David. I'll read it out for everyone. If we assume that David Autor is right, does that mean we can ignore the bottom end of the geographically flattened labor market and just focus on the top end of the skills and wage distribution?
So the way I was thinking about this, that innovation might be able to lift the bottom end of the labor market. Does that make sense? Or do you disagree with it?
Yeah, well, I don't disagree. It's just, I guess, you know, how many how many cups of latte can the techies drink or something, you know? I mean, there's got to be some point at which, you know, in many areas, well, actually, it's going to be very interesting if a lot of what we're hearing about the impacts, the longer run impacts of COVID are right, in the sense that there'll be far less demand for perhaps high-skilled workers in central city areas. I'm not really sure what I think about that. Then, you know, you might actually see some significant declines at the bottom end as well. So, I mean, I think I was not meaning to really ask a question, just respond a little bit to Michael's comment on Auteur, thinking that, you know, it might help us a little bit in, if this flattening is observed pretty much everywhere, you know, maybe we can specify a somewhat simpler model and just focus at the top end. But I think we need to do a little bit more work to check on that argument first.
Yeah. Yeah. So what I'm trying to get at, I guess, is that does innovation not just create those coffee shop jobs, but does it create sort of intermediate skilled jobs that do get people out of that ultimately? Those like very bottom end jobs. Does it create more intermediate jobs? I think that's probably another Auteur paper where they're showing that those jobs are essentially getting lost. So do these, does innovation sort of create those intermediate level jobs that are otherwise being lost at a high rate?
Great, Carolin, I'm gonna let you push ahead then. So some great questions that we had, and then of course we'll have more time at the end.
Yeah, thanks so much for the comments. So the way I'm trying to estimate this, basically I'm exploiting the time series nature of the data, because obviously there's a lot of endogeneity and all of these problems that we sort of discussed right now. So what this local projections method does is I'm estimating change in one of my outcome variables on basically the other independent variables. So let me start again. So there are obviously a lot of endogenous variables. I have the graduate employment and patenting, which sort of depend on each other. And then I have the non-graduate employment. So here I'm showing the example of graduate employment. So I'm estimating the change in graduate employment over growing time horizons. So from year T-1 to year T+1, to year T+2, and so on and so forth, on changes in patenting with several legs. And then I can plot these beta ones for the different time horizons and sort of see how graduate employment responds to an innovation shock. And as I mentioned, I'm trying to also separate the graduate employment variable into one that is due to the patenting shock, and then one that is due to sort of other shocks. So what I'm doing is I'm estimating graduate employment on all the control variables that I have available, and I'm estimating that both with patents included and without patents included, and then the change in graduate employment due to innovation would be the difference between the fitted values of those two regressions. So essentially, I'm kind of trying to isolate the variation in graduate employment that is induced by the innovation shock or by the patenting shock. And I mean, that again requires lots of assumptions, particularly the innovation shock has to be uncorrelated with other variables explaining change in graduate employment, and that's probably a bit of a questionable assumption. But yeah, that's where I'm at the moment. So here's the data set that I'm using. I'm mostly relying on Eurostat data. So I'm looking at hourly wages, employment. The patent data comes from the OECD, and I also look at the unemployment rate. The coverage of the data sets varies a little bit by country. That's a bit unfortunate. But yeah, let's just look at some maps of what this data looks like. So here we have snapshots in 2016 of the SNUTS2 regions. On the left, there's the number of patents granted, and on the right, there's the hourly wage. So for example, for Germany, we do see a bit of a correlation there. So the regions in the Southwest that are stronger in terms of patenting, they also pay higher wages on average. In France, we also see, well, there's the Ile-de-France that has a lot of patenting and also has higher wages, but let's not pretend that those high wages are just because of the patenting. That's also the capital region. So there's lots of other things going on as well. And then in France, we also have the Rhône-Alpes region, which is very strong in terms of patenting. In the UK overall, there's less patenting overall. So that's a bit of a problem as well. Then here's some other variables. And I think this is a bit problematic because there we really see that there's sort of big differences across countries. So on the left, there's the graduate employment share. And we see that in Germany, the share of graduates in employment is overall much lower because there's the stronger sort of vocational education system. So fewer people go to university overall. And well, in the UK, it's essentially the opposite. So the share of graduates is overall much higher in the population. And then on the right, there's the unemployment rate. And again, there are these sort of country level differences. So in France, unemployment is overall much higher. In Germany, there's still the sort of East-West difference. And well, in the UK, it's also mostly a regional story. There's a question.
It was on your previous slide.
Yes, sorry. No, this is just the raw number of patents at this point. Yeah, I could normalize that by population. That's one other thing to do, yes. But this is just the number of patents in that 1 year.
Yeah, I think if you should look at the, I mean, if possible, you want to also try to deflate it by the type of employment in each area. So with Eurostat, you can look into the occupations within each area. And so somewhere like in the UK, you can also at least understand like what would be identified as a patentable occupation. I think Nesta publishes something like that for the UK. And try different deflators because it's obvious the number of patents vary, but I think what's more important, especially for geographical analysis, is rather what is the denominator.
Yeah, so in my regressions, I'm looking at yearly changes. So I think, I mean, population doesn't change that much year on year, and I think, yeah, you're right, but it does get very difficult because then obviously, you know, London has a very low number of patents, although it's the densest region. So yeah, but that's exactly one thing that I want to show with this map as well, that there's these sort of differences across countries that are, I mean, due to a lot of things, due to industry structures. So it's not just, you know, it's basically complex, but thank you, yeah. Yeah, so again, there are, exactly as you just mentioned, actually, there are sort of regional factors, that's like density and overall population size and that sort of stuff, but then there are also these sort of country level sort of policy preference problems, like a lower share of graduates in Germany, obviously overall a higher employment rate in France. Unemployment rate, sorry. So let's just start looking at the results, and then maybe I can pause again after this first set of results. So these are essentially these coefficients that I'm plotting that I described earlier. So here we have the response in patenting to a graduate employment shock. So overall, we don't see a big effect here. Basically, patenting doesn't respond much to graduate employment, and in the end, there's even a little sort of negative effect. However, graduate employment does respond to patenting, so that's sort of the effect of a highly innovative region attracting graduates over time. So in the first years after patenting shock, this effect is insignificant, but it does grow significant after 3 years. And here in the bottom panel is the effect that I'm actually interested in. So this is the graduate employment response to an innovation shock. And again, it's insignificant. I'll go later to the sort of country-specific effects, and there the picture looks a little bit different. And here is the non-graduate employment response to graduate employment shock. So this is the sort of overall effect. So to any graduate employment shock. And here's the response to a graduate employment shock induced by the patenting shock. So this is what I described earlier, where I'm trying to separate the variation in graduate employment due to the variation in innovation. So the point estimate sort of turns positive after a couple of years, but it remains insignificant. Maybe I'll pause quickly here if there are sort of any methodological questions. Are these graphs clear what they mean?
Yeah, we might have 3 to 5 minutes for some questions on these if anyone has a question.
Carolin, you have I'm looking at I'm thinking about the model specification and what the note says at the bottom. You've got lags of your dependent variable on the right-hand side.
Yeah. Mm-hmm.
So you can't run a standard fixed effects model. When you lag, you violate, you generate a number of issues. I've just forgotten what the specific type of. You can run a fixed effects model, but it has to be of a particular kind. Gosh, and I can't remember what it's called.
Thank you. I didn't know that.
Yeah, I'll send you an email with the note.
Okay.
You introduce autocorrelation when you have lags, and that causes problems all over the place.
Okay, yeah, that's good to know. I was a bit worried about that, but yeah, I just ran it regardless, but that's really good to know. Yeah, if you can send me that paper, that would be great.
Yeah, will do.
Work on that. Thank you. That might maybe explain my huge standard errors as well. Okay, so if
can I ask a quick question? How do I interpret the y-axis values? Are these because a patenting shock is not a binary variable, right? It's just a change in the patent count coming from a region. So is the y-axis in these charts the marginal effect of an increase in one patent increases graduate employment growth rates by 0.01 or so by 1%? Is that how I interpret this? Yeah, so essentially how I interpret it is just like an elasticity, because I'm regressing growth rate on growth rate. Okay. So if there's a 1% shock to patenting, that would be like I think it's a 0.1% change in employment growth, but now I'm not sure if it's a 0.1% or a 1% change. I think it's a 1%, but maybe somebody wants to chime in on that. Okay, so that was my question. Just a quick FYI, you didn't have the logs or the percent change in the regression model, so I got a little thrown off. But this makes sense then. So thanks.
Yeah.
Okay, does anyone else have any questions about these kind of baseline results? All right, yeah, you feel free to press on.
Thank you. So here we're looking at the country level specific regressions. So this is, again, sort of the first set of results where I'm just looking at graduate employment and innovation. And this is broadly the same across countries. So again, not really an effect of graduate employment on patenting, but we do see this positive response of graduate employment to patenting, mostly in France and Germany, not so much in the UK. And I guess that is just because patenting overall in the UK is quite low, so the changes might not be as meaningful there, and graduate employment might just, they're less related. So let's look at these effects on non-graduate employment. And I think the most interesting effects are for France. The other two countries, I'm struggling a little bit with interpreting them. And I think that's due to all these sort of data issues that we discussed in the beginning. So here in the upper left corner, we see the non-graduate employment response to a patenting shock. And that is broadly positive over the whole period. Then there is the non-graduate employment response to graduate employment shock, and that's kind of insignificant. It turns positive towards the end of the period, but it remains statistically insignificant. So this would be sort of the consumption multiplier that I would be thinking about. Graduates consume local services, and that creates sort of local service economy jobs, but we don't really see this effect here. And this is the response to the graduate employment shock induced by the patenting shock. So my sort of interpretation of this would be that these would be the sort of support level or application type jobs that hopefully would be higher skilled. But again, we can't really say that with the data I have available right now. That would be something to look at with more industry level data or a little bit more detailed data. But this is sort of the effect I was looking for, that there is this, first of all, this separate effect of innovation on on non-graduate employment, but then also the specific innovation graduate effect. And we can briefly look at the other countries, but yeah, I think there are problems. So, well, for Germany, so the effect of patenting actually looks good. There's this strong positive response. However, then the response to graduate employment of non-graduate employment is sort of strongly negative in both cases, and I can't really have an explanation. I don't really have an explanation for that. So I think that might be data issues to some extent. I also have to check if there are any outliers or any years that are sort of driving this, but I really can't explain this. And then again, for the UK, it's mostly insignificant. So then one other thing I'm looking at is hourly earnings, and here I'm looking actually at different industries because I don't have data for earnings by qualification or by skill level. And I'm only looking at Germany and the UK because I don't have the data for France for enough years. But basically I'm running a similar regression to before. And I'm looking at the effects of patenting and of graduate employment on wages in these different sectors. So here we don't actually see any effect of patenting on wages in both countries, but we do see a positive effect of graduate employment on wages in most sectors. Now that is of course some of these graduates will be employed in those sectors. So again, these are to some extent correlated. So yeah, in the UK, for example, the most significant effects, well, are in finance and insurance. So this isn't really the sort of channel that I'm looking at. And then the other effect is in arts and recreation. So that would be definitely the sort of consumption channel. So let's just, as a brief outlook, so this is the sort of new data set that I'm trying to work with and that I'm looking at. This is the European Social Survey, which is run every 2 years. And it has a lot of very detailed information on people's qualifications. So it does ask for a very detailed sort of degree, not just like, do you have a degree, but it also asks by bachelor, master, PhD level, and then also for different sort of levels of vocational qualifications. And then it also asks for the occupation the person is working in at the moment. So we can sort of, from that, hopefully get a bit more of a detailed picture of what is actually happening in those local labor markets. And these are just the correlations with patenting. These are sort of bin scatters pulling together a couple of regions and a couple of years for each dot. And well, these are sort of advanced vocational degrees. I pulled a couple of degree qualifications together there, but they are basically all undergraduate degree, but sort of, yeah, higher vocational qualification. And unsurprisingly, sort of for the UK and France, there's not really any relation. Well, it's quite negative here, but basically there's not much variation in sort of people with these advanced vocational qualification. For Germany, the correlation is still positive, but there are much more people with these sort of degrees. And I think, yeah. Then we're looking at people who have more than an undergrad degree, so that would be a master's or a PhD, and there the correlation is positive overall. So yeah, more people with more advanced degrees are actually correlated with patenting quite strongly. And then I'm also looking at sort of science, research, and technical occupations, and again, there's sort of this positive correlation with patenting. So yeah, that's sort of what I'm working at the moment, getting a bit more out of this data, and hopefully that can improve my estimates a little bit. So yeah, just as a brief conclusion, and then maybe we can stop the recording and have more of a discussion. So I do find this positive effect of patenting on graduate employment. The reverse is not the case, so I don't really find an effect of graduate employment on patenting. There is a positive effect of patenting on non-graduate employment, but it's quite small. And again, it depends a lot on the country context, so it's strongest in France. I do find a positive effect of graduate employment on hourly wages, but again, that depends on sector. And there's this problem that some of that might also actually be because there's more graduates working in those jobs. So yeah, as I said, I'm working with the new data set. And I think, yeah, looking more at the sector level and maybe also distinguishing patents more by technology might be useful. So maybe I'll stop there and can take on any other questions. Sorry, who was that?
Okay, well, so thank you, Carolin, for the great presentation. I'm going to hit stop recording now. We can open up to a general Q&A.